Hi, I'm Tim Berglund with Confluent. I don't think you'll be surprised to hear me say that stream processing isn't always easy. It can cost a lot of development time to get right. I want to show you how Confluent Cloud can help you get some of that time back. A lot of us are new at stream processing, and the infrastructure itself can be difficult to stand up on its own. Sometimes you might have to support several different distributed systems and get them working together just to accomplish basic things like distributed logging, integration with external systems, and real-time stream processing. Even with Apache Kafka, which is a mature and stable ecosystem, there can be a lot to think about, and you might find yourself repeating work that others have already done. How do you avoid this trap? One way is to use a fully managed Kafka service like Confluent Cloud. For our purposes here today, I want to look at two features: KSQLDB and Connect. KSQLDB provides a fully managed stream processing solution with a SQL interface, so you can do stream processing, but with a smaller learning curve and a lot less development time. Connect is a fully managed integration framework with pre-built connectors that let you connect to data sources and sinks outside of your managed Kafka cluster. You configure them and they run. You don't spend precious development time writing undifferentiated integration code. Instead, you can focus on code that directly serves your customers. So let me log into my account in Confluent Cloud. You can see I have an environment and some clusters already set up. They happen to be of the basic and standard cluster types, which are two types of clusters that you can spin up in your account right away with just a credit card. Basic and standard clusters differ in some ways that you can see here. Let's go over here to the Connectors tab and set something up. At the time of this recording, these are the connectors we've got in preview and in general availability. You've got MongoDB, Snowflake, the various cloud blob stores, and the various cloud messaging systems. But this list is always growing. Now, notice we've already got a connector running here. This is a source connector, meaning it's reading data from an external system and producing it to a topic in our cluster. In this case, the external system is Google PubSub. That's GCP's native messaging system. We're bringing in messages from there into Confluent Cloud. Now, I've got a Postgres instance running in Amazon RDS, and I'd like to get data from that database into a topic in my cluster. To do that, I add a new connector, give it a name, and enter in the various configuration parameters the connector needs. Normally, I'd type all this into a JSON file, so I have to say personally, I enjoy this page. And there's a quick look at the resulting JSON if you just like looking at JSON. And then we'll launch the connector. Here we can see that it has, in fact, read some data from the Postgres database. You can even scroll through those messages in the Confluent Cloud Connector UI. Next up, I'm going to create another connector, but this time using the command line interface. I want to make an S3 sync connector. So we're going to be sending messages from a topic to an S3 bucket. And all of my config lives in that JSON file that we've written specifically for this purpose. I know I just got done saying I like the web form approach, but you know full well that sometimes you want to work with source-controlled config files instead. And you can. With that, we've got an S3 sync connector moving data from our topic into a bucket in S3, as you can see here. So to summarize, data is coming from Google PubSub through a fully managed connector into a topic, back through another fully managed connector to an S3 bucket. That's how easy integration is in Confluent Cloud. You can integrate with best-of-breed, cloud-native, and open-source technologies using a constantly growing library of connectors. But of course, you don't just want to move data through a topic, you want to actually perform computations on that data. That is, you want to do stream processing. And you don't want to spend weeks or months standing up a framework to do it. That's what we'll look at next. Stream processing with KSQLDB. The first thing we do is to create a KSQLDB application. An application is like a namespace for KSQL queries. We'll go with the default number of streaming units, which was 4 in this case. And a streaming unit is like a measure of how much computational work a KSQLDB cluster can do. It's kind of like cluster size, but in a cloudy sort of way. Now let's shell back out to the shell and see if we can see our KSQLDB application. And there it is in the list. We'll need to set up some ACLs to let our application access the topics in the cluster. Security is a good thing. Next up, let's do a quick sanity check by inspecting the contents of the Postgres source connector account topic we created earlier. And we're going to do that using the KSQL print command. This shows us we do, in fact, have data in that topic, which is good news. Next, let's create a KSQL stream. A stream is a lightweight abstraction on top of a topic. And remember, we're still working with Postgres source connector account, that topic here. This will allow us to write KSQL queries on the data in that topic. We'll set a couple of parameters and create the stream. Now I can write a quick select statement, in this case a stateless filter, for any messages with Confluent email addresses in them. And we see that there are several. Although none of these people look familiar, I might have to look into that. I'd like to make that query a bit more official, so rather than just a select whose results I can view in the UI, I want to create a persistent query. This is a query that will run continuously in my KSQL DB application. Remember that scalable query namespace we created a few minutes ago? Always consuming messages from my source topic, always producing messages to a new topic called, in this case, external users. When I hit run query, this query truly will run indefinitely, which is the nature of stream processing programs. In fact, I can now go over to the Run Queries tab, and you'll see it there happily running along like a dog after a mail carrier. And don't forget the flow view. Here we can see the source topic, our create stream query, and the destination topic with our results. Now, this query was very simple because there's already a lot to take in this video, and I didn't want a bunch of complex KSQL going on. But you can see how even with a slightly more interesting query, and maybe a pipeline of queries processing each other's output in a chain, this view becomes absolutely essential to understanding and visualizing what's going on in your hosted stream processing systems. So maybe stream processing isn't easy, and maybe the infrastructure feels like a pain. You're tempted to rewrite data integration code that doesn't differentiate you to your customers, and to solve a lot of complex distributed state and real-time processing problems that have already been solved. But you don't need to do any of that. With Confluent Cloud connectors and KSQL DB, you've got so much of what you need right in front of you without having to incur any development cost on building a bunch of framework that lots of different people have already built. So check it out. Sign up on Confluent Cloud, start pulling in some data and writing some KSQL DB applications to process it. Your development time may be one of the primary limiting factors for moving your business forward, so you might as well save all you can. And as always, I look forward to hearing what you build.